Okay, so today I'm going to go through numbers 1 through 10 on the purple test out of the blue BC binder. Um, so here we go. So this first question says we have sine of 3x, then dy dx is equal to what? So we know the derivative of sine is cosine, but we also know by the chain rule you have to multiply it by the derivative of this. So it's times 3. So the answer is going to be 3 times cosine of x or cosine of 3x, so the answer is E over here. Okay, number 2. Okay, now we don't need to do it this way, but I'm going to do it like you would do it on a free response question. So you know that when you take the limit of this, the very first thing you have to do is you have to break it in. And remember, on the free response questions, you do need to break it apart. So you have the limit as x goes to 0 of e to the x minus cosine of x minus 2x, and then all over the limit as x goes to 0 of x squared minus 2x. Okay, so we plug it in. So you go, this is e to the power of 0 minus cosine of 0 minus 2 times 0 all over 0 squared minus 2 times 0. So this is going to be 1 minus 0 all over 0 minus 0. So you get 0 over 0, which we know is one of those indeterminate forms. So we have to use L'Hopital's rule. So make sure to state this to the reader. This is multiple choice again, so you don't need to do this. But when you do do this on a free response question, make sure to put this in that way. Okay, so now we have to use L'Hopital's rule. So we're going to go ahead. So I'm just going to adjust this a little bit. So now we're going to go ahead and take the derivative of the top and the bottom. So we know by L'Hopital's rule, this is equal to the limit as x goes to 0 of, and then you take the derivative of the top and put over the derivative of the bottom. So the derivative of the top is going to be e to the x minus the derivative of cosine is negative sine. So that'll be plus sine of x minus 2 all over, and then the derivative at the bottom is going to be 2x minus 2. And so when you plug it in, you go e to the power of 0 minus sine of 0 minus 2 all over 2 times 0 minus 2. And that gives me 1 minus 2 all over 0 minus 2 gives you negative 2. So this is negative 1 over negative 2, or 1/2. Okay, so the answer here is going to be C. Okay, next question, next page. Okay, so we go right here. Okay, so now we're evaluating the integral of 3x plus 1 to the 5th power. You notice that this is really just a power rule. The derivative of the inside is just a constant, so I can just treat it as such. So you just have to raise by the power of 1 here, divide by it, and then also divide through by the derivative of 3x plus 1. Okay, so in doing so, you have 3x plus 1 to the power of 6 all over 6. But once again, you still need to, instead of multiply by the derivative of the inside, we're dividing by it because we're integrating. So you're going to divide through the derivative of the inside, which is 3. So this is 3 there, and then I have plus c. So I have 3x plus 1 to the power 6 all over 18 plus c. And we go over here, and the answer is going to be A. Okay, so next one. Okay, so for every t between 0 and 13, an object travels along an elliptical path given by the parametric equations x is equal to 3 cosine t and y is equal to 4 sine t. At the point where t is equal to 13, an object leaves the path and travels along the line tangent to the path at that point. What is the slope of the line in which the object travels? Okay, so you have some sort of an object that's traveling in an elliptical path like this, and its path is given by the parameters or the equations x equal to 3 cosine t and y is equal to 4 sine t. So we know, because it's asking for the slope, slope is dy dx. But since we're in parametric equations, this is dy dt all over dx dt. So this is going to be equal to, so the derivative of y with respect to t is just going to be 4 cosine t, and the derivative of x with respect to t is going to be negative 3 sine of t. Now, I do need to plug in 13 here because I need to evaluate it there. So plugging this in, I know dy dx evaluated when t is equal to 13 is equal to 4 cosine t, 13 all over negative 3 sine of 13. Now you notice none of those answers are up there, but there are these tangents that are there, and we know tangent is sine over cosine. This is cosine over sine, so this is equal to, and I'm doing more steps than I really need to here, but I want to make sure you guys understand, negative 4/3 times cotangent of 13, which is equal to negative 4 all over tangent over 3 tangent of 13. Okay, so we go up here, the answer is going to be D. Okay, next question. Okay, so here's a Euler's form method question. Okay, so we're letting y equal to f of x, and that's going to be the solution to this differential equation with the initial condition f1 is equal to 2, so that is our initial point. That's going to be our x naught, y naught point. Okay, what is the approximation for f of 2 if Euler's method is used starting at x equal to 1 with the step of 0.5? So we know we're going to start off at x naught, y naught, and that is going to be the point that's given as 1, 2, which we got from right here. When you plug in 1, you get out 2. And then you know that we have to go x1, y1, and I know the x value. So the x value of x1 is just going back to x0 and adding on what would be the step of 0.5. So this is going to be 1.5, comma, and then I have x2, comma, y2, and that's going to be equal to, the x value is going to, you go back to the prior x value, and you add on what the step would be. So 1.5 plus 0.5 gives me 2, and that is where I wanted to go to. I wanted to go to 2, so I don't need to go any further than that. Okay, so now we just have to evaluate the y values. So the y values, if you remember what you do, you go back to the prior y location, or the prior y point. So this is going to be 2, plus you add on the step, and the step is 0.5, and they have to multiply it by the derivative at the prior spot. Well, here's the derivative. I have dy dx is equal to x plus y. So the derivative, dy dx, evaluated at the point 1, 2, which is the prior point, is going to be equal to 1 plus 2, which gives you 3. Okay, so this will be 3. So when you do this, then you have the coordinate 1.5, comma, 2 plus, and this will be 1.5, will give you 3.5. Okay, now we just have to find the y value here, and we're done. So we repeat the process. You go back to the prior y value, so 3.5, plus you add on the step of 0.5, times the derivative at the prior location. So dy dx, evaluate at the coordinate 1.5, comma 3.5, is equal to 1.5 plus 3.5, which is equal to 5. So we come over here and you plug that in right there. And so then that's going to be 2, comma 3.5 plus 2.5 is going to be 6. So the answer is 6. It's right here. We have C. Okay, down here. for which, what are all the values of p for which this integral from 1 to infinity of x to the 2p over 1 converges? Now, a couple of things here. I don't really need to account for this very much, but I do need to take note that it's actually going from 1 to infinity. That's important. This doesn't necessarily apply if it's not from 1 to infinity. But if it goes from 1 to infinity, this is simply just a p series. And I know that this will only converge if the power here, 2p, is going to be greater than 1. So we solve, where p is greater than a half. So you go over here, so the answer is going to be C. Okay, next question. Okay, so the position of the particle moving in the xy plane is given by the parametric equations x equal to this, well, x is equal to t cubed minus 3t squared, and y is equal to 2t cubed minus 3t squared minus 12t, for which values of t is the particle at rest. Okay, um, so in order for it to be at rest, I know it can't be moving in both the x and the y direction. So what I know then is I know that dy dt has to be equal to 0, and I also know that dx dt has to be equal to 0. So let's calculate dx dt and dy dt. So dy dt is going to be 6t minus 6t squared minus 6t minus 12. And I have x prime is going to be 3t squared minus 6t. So let's set these both equal to 0 and solve. So here, I'm going to have 0 is equal to 6t squared minus 6t minus 12. We can divide everything through by 6. So I have 0 is equal to t squared minus t minus 2. And that factors into t minus 2 times t plus 1. So therefore, t is equal to 2 and t is equal to negative 1. Okay, so down here, we're going to have 3t squared minus 6t. I'm going to set that equal to 0. Once again, you can divide through by 3. And at the same time, we're going to factor out a t. So I have t times t minus 2. Make sure you guys can understand that because I did skip a step. So I divide 3 by 3, and I factor out a t. And so then this gives me t is going to be equal to 0, and t is going to be equal to 2. Okay, now in order for it to be stopped, it can't be moving in either direction, which means it has to be the intersection of these times. And as you can see, the only intersection you have is when t is equal to 2. So t is equal to 2 is the only time that it is stopped. Okay, next one. Okay, so down here, I'm going to do this real quick way, and then I'm going to actually show you using U substitution. So you're integrating this, and you have two different things that are going on here. The key to doing this is noticing that x cubed, the derivative of x cubed is x squared. So in other words, this is really nothing more than just integrating cosine of u. That's it. So you notice you get back the same answer. So the integral of cosine is sine. So it shouldn't be a negative. So we have sine of x cubed. So it's one of this one, or this one. And then I know by the reverse chain rule that you're going to divide through by the derivative of this. And the derivative of this is 3x squared. So x squareds will cancel, and you just have it divided by 3. So the answer would be then B. Okay. Now, if you didn't understand what the heck I was talking about, let's do this using U substitution. Okay. So I'm going to let x or u equal to x cubed. So then du is equal to 3x squared dx. And then remember, my method to doing this is solving for dx. So you have dx is equal to du over 3x squared. Okay. So now you go back and plug everything in. So this will be the integral of x squared times cosine of x cubed, but x cubed is u, dx, but dx is du over 3x squared. As you can see, the x squareds go away. This is just 1/3 times the integral of cosine of u du, which is equal to 1/3 sine of u plus c, plugging back in what u is equal to. So this is 1/3 sine of u, which is x cubed, and then plus c, which once again is my answer B. Okay, two more. We're almost done. Okay. Okay, so going here, if f is equal to ln of x plus 4 plus x, or e, to negative 3x power, then f prime of 0 is what? So I just have to remember how to take the derivative of ln. So remember, if you have y is equal to ln of u, then y prime is equal to u prime all over u. So you take whatever this is, you drop it to the bottom, you multiply by the derivative of what's on top. Okay, so the derivative here then, f prime of x, is going to be equal to, so on the bottom, you just drop everything there to the bottom. So x plus 4 plus e to the negative 3x. And then on top, you have to put the derivative of what is here. So the derivative of x is just 1. The derivative of 4 goes away. The derivative of e to the negative 3x, so this is my moon. So I'm going to multiply, so I have, so I get back the same thing, but I still have to multiply it by the derivative of negative 3x because of the chain rule. So this is minus 3e to the negative 3x. And I just have to plug in 0. F prime of 0 is equal to 1 minus 3. E to the power of 0 is just 1, so I'm just going to leave it like that. All over 0 plus 4 plus, once again, this is 1. So I have negative 2 over 5. So the answer is A, negative 2/5. Okay, and then the last one for the set. Okay, what is the value? Boom, right away, you know that we only know two ways to do this. Okay, geometric, and the second way is going to be telescoping. So when you look at this right away, you have 2 over 3, they're both raised to an n power, so you know it should be geometric. So we just have to manipulate this to get it into that form. So this is equal to the sum, as n goes from 1 to infinity, of 2 times 2 to the n, that's just rewriting this, all over 3 to the n power, which is equal to 2. 2 is just a constant, so I can bring it out front in the summation, as n goes from 1 to infinity, of 2 over 3 to the power of n, and there's your geometric. Okay, so this is an infinite geometric series, so you know the sum of this infinite geometric series is equal to a1 all over 1 minus r, where a1 stands for the first term when you plug that in. Where you're going to goof up with this question is you're going to forget about the 2. Don't forget about that 2. Okay, the common ratio is just what this is, so it's 2/3. So this is going to be equal to, okay, so a1, so I plug in 1 to this equation, and I get 2/3. But this 2/3 will be multiplied by 2, so this is actually 4/3 on the top, all over 1 minus the common ratio, which is 2/3. So we have 4/3 over 1/3, which is going to give me 4. So the sum of this infinite series is going to be 4, so the answer is C. Okay, I hope that made sense to you all, and I'll see you soon.